Question 7 is still looking at electron configurations and how many electrons happen to be in the valence shell. Just a few things to point out here. Valence electrons, this is the total number of electrons in that outer shell, or what we call the valence shell. So it's a little different from the total number of electrons that we have. And then valence specifically is the number of unpaired electrons. Okay, so keeping all of that in mind, if we go through here and we start looking at it, first off we have an oxygen. If you have an oxygen atom that has a zero charge or a neutral charge, then it's going to have the same number of electrons as we have protons. So if we go to the periodic table, oxygen always has an atomic number of 8, which means that a neutral oxygen is going to have 8 electrons. And so the number of occupied electron shells, to know that, you would draw the electron configuration. So if I draw it right here, here would be my first shell holding 2, then I would have another 6 electrons. So I'm going to put those on here. And so when I do that, I can see that I actually have 2 occupied electron shells. The total number of valence electrons, that would be all of the electrons in the valence shell, which if you look here, we have 6 of them that are in the valence shell. And then the valence is the number of unpaired electrons, and there are 2 unpaired electrons. So if we just circle them, that one and that one, those would be our unpaired ones, which are going to be equivalent to the valence. So I'm going to put 2 right here. The next one is magnesium, and magnesium in this case has 10 electrons. So if we draw that electron configuration, we know we have 10 electrons. So I'm going to put 2 on the first shell, then I move to the second shell, and we're going to have to fill up the second shell to actually get our 10 on there. So we have filled 2 shells. The number of valence electrons, we have 8, and the valence is going to be 0 because we don't have any that are unpaired. The one other blank spot that we have here is the overall charge, and remember that the charge is going to be equal to the number of protons minus the number of electrons, which is 10. So if we do go to the periodic table, if we look here, we see that magnesium has an atomic number of 12, so it has 12 protons. So if I fill this in, I've got 12 minus 10, so that charge is going to be equal to plus 2. So I can fill that in here. The next one, we don't have the element's name written here, but the other information that we do have is that it has a neutral charge and we have 15 electrons. So if we have a neutral charge, if we write that here, and we know that we have 15 electrons, we'll notice that the number of protons must be equal to 15. So we want to take that information, go to the periodic table. The box that has the 15 is phosphorus, so that is the element that we're dealing with. So I can write that in here. And then we can draw the electron configuration. Okay, so I've just cleared a little bit of space here. If we draw the electron configuration for our neutral phosphorus, we're going to have the first shell with 2. The second shell, we're going to end up filling that up completely. So as I move around the circle and put my 8 in the second shell, now I have done 10. And then I'm going to add yet another shell, and that next shell, the third shell, is going to end up with 5 in it. So the number of occupied electron shells will be 3. The number of valence electrons, we have a total of 5 electrons in the valence shell. And then the number of unpaired electrons in this case is going to be 3. The very last one here, chlorine. We have a chlorine atom that has a charge of -1. So if my charge is -1, we want to take the number of protons. So let's look that up. So if we go here, we know that chlorine has 17 protons. So I'm going to put here 17 minus the number of electrons, and that's going to help me figure out how many electrons I'm dealing with. In this case, E is going to be equal to 18. And now we can draw the electron configuration. So for chlorine, fill up the first shell. Then we draw the next one, which is going to get filled up as well with 8. And once that's full, we'll draw yet another shell on here and then put the rest of them in that. So when we look at that third shell, which is how many we've occupied. The third shell is going to have a total of 8 electrons, and the total number of unpaired electrons is going to be 0. When we get to number 8, we're taking that information where we drew the electron configurations and we're using it to predict covalent bonding. And so with this, you really need to know what that valence shell looks like, because the number of covalent bonds, this is going to be equal to the number of unpaired electrons. Or in other words, this is going to be equal to what we were previously calling the valence. Okay, so keeping that in mind, when you draw the electron configuration of hydrogen, if we draw that here, hydrogen has 1 electron, so this is what its electron configuration looks like. So hydrogen is going to make 1 covalent bond because it has 1 unpaired electron, and so it will end up sharing 1 electron with another atom. When we look at the next one, carbon, if we draw carbon's electron configuration, carbon has 2 on the first shell and it ends up having 4 on the next. And so with that, we have 4 covalent bonds that it's going to make, and it's going to end up sharing 4 electrons. If we move along and we look at oxygen, oxygen is going to have 8 electrons, and we just drew the electron configuration of oxygen, but if we draw it again here, you get 2 on the first shell, we're going to end up with another 6 on the second shell, and when we put those 6 on the second shell, you have 2 unpaired electrons, or a valence of 2. So we're going to get 2 covalent bonds, single covalent bonds, and we'll share 2 electrons. Nitrogen is next up. Nitrogen has an atomic number of 7. We draw its electron configuration. This is what we would have. There are 3 unpaired electrons, so we're going to get 3 single covalent bonds, and we will have 3 shared electrons. Fluorine is going to have an atomic number of 9. So when we draw that one, 2 on the first shell, we have another 7 that we can put on the second shell. And since there's 1 unpaired electron, there's going to be 1 single covalent bond and 1 shared electron from fluorine. And then the last one here, that's neon. Neon has an atomic number of 10. And so it is going to have a full first shell, and we will end up with a full second shell as well. So when we get that, we have no unpaired electrons, which means that neon does not want to make any covalent bonds. So we're going to have zeros for both of those columns.